left off in the last video with results of an analysis that unfortunately had a problem. And that was that note that we got from SPSS telling us that one of our cells had an expected count less than 5. And so I promised you at the end of that video, well, I'll show you how to fix that problem. And the good news is it's not really that hard to fix, but it does require you to do a little bit of data transformation. So in short, the solution when you have cell counts with expected counts less than 5 is to combine some of your categories. And it's not always obvious the best way to do this, because sometimes you have different options. But it almost always includes either collapsing multiple categories into fewer categories, or sometimes you can even filter. You can filter out one of the groups. So one of the potential options we would have had here in this situation with country music and race is we could filter out the other group and just do a test of black and white against preference for country music. And that would take care of that cell. But I think that fundamentally changes the question that we're asking to just eliminate everyone in the racial groups outside of black and white. So the less damaging thing to do to our analysis from a substantive point of view is to collapse scale points. And that's usually going to be the better option in most situations like this, rather than eliminating one of the groups that's potentially of great interest to you, but just to collapse some of the scale points, turning a 5-point scale into a 4-point scale, or sometimes turning a 7-point scale into a 5-point scale. If you remember, if we go back to the output, actually I'm going to scroll back to the couple of slides. I'm going back to slide 13. The scale point that was problematic was dislike very much. It's one of the extremes. It's usually going to be one of the extremes. And so within the other category, which was the smallest of the racial categories, and in one of the extreme scale points, we had an expected count that was less than 5. Now, the best solution, if you can pull it off, to avoid this problem is just have bigger sample sizes. And the more that you work in the realm of data, the more that you find that, big sample sizes solve a lot of problems. But usually that's not an easy fix. I mean, more often than not, once we're at this stage, the data are what they are, right? You can't just go like, oh, well, just give me 100 more cases. It doesn't usually work that way. So looking at this as we've got 1,574 cases, and that's what we have to work with, the option that probably makes the most sense here is to combine dislike it and dislike it very much, which the actual values on that scale, if you recall, are 4 and 5. So we're going to take the 5s and just recode them into 4s. And so the scale will go 1, 2, 3, 4, where category 4 now will include both dislike it and dislike it very much. So here we are again. Here's the data file. And the first step is to create a new version of the country music variable. Right, so we can go to the transform menu. We're going to go to transform, recode into different variables. And again, the idea here is we're going to create a new version of that variable. So I'm going to display the variable names. Again, I don't want big band in there, actually. I want country. So I'm highlighting country, and I'm going to pull that in. Now, if you look here, it says input variable to output variable. But as soon as you pull country in, SPSS recognizes it as a numeric variable. Even though we're treating this as categorical, it is numeric in the sense that it's numbers, and we've set it up so that you could do math with it. So that's why that just changes, but it's still the input variable spot. So I have to name the output variable. I'm going to call it country2, and I'll give it the label country version 2. It's another transformation of the same variable. And then I click the button change, and you can see SPSS has got the setup for country is going to beget country2. Once you've got this set up, you can click on this button down here, old and new values. And now we don't want to change anything that's values 1 through 4. So we can go under old value on the left here. We'll click on range and we'll say 1 through 4. We are just going to copy the old values. Under new value, click on copy old values. Then you have to click add. And so in this box here, it's going to give you the summary of what you're going to do. So 1 through 4, we're just going to copy. And what we decided we would do is we would change anything that's a 5 into a 4. And I click add. Now, we did have other values in here. We had 0, 8, and 9. They're being treated as missing. If I don't do anything with those, it's just going to, in the new variable country 2, it'll just be missing. So that's fine. That works fine for us. So I'm not going to do anything else with it. But you could specifically say, all other values and make them system missing. But it'll automatically do that. I guess if we want to be, thorough, we could do this. Okay, so I click on continue. And then I will click on paste. If I go back over here into my syntax editor, you'll see this is what the syntax looks like for recoding a variable. We're recoding country. It tells you 5 equals 4 and 1 through 4 equals copy, else missing, into country 2, and we're giving it the variable labels, or the variable label country version 2. So if I highlight this and I hit run, and I come back over to the data file, you'll see now here in the variable view, there's a new variable country 2. That's country version 2. If I were to go into the data view, scroll over, you would see country 2. I don't have to do this, and in the PowerPoint deck I didn't, but this might be worthwhile to look at. There are no values associated with this new variable. I didn't create them. Remember, when we were running analysis on any of these variables, it doesn't tell you 1, 2, 3, 4 in the output. It doesn't show you the codes. It's showing you the labels. If there are no labels, it would just show you the codes. I'm actually going to copy, so you can go into SPSS and any of these variables, just copy it. I'm doing Control C. And then I'm going to come over here to country 2, and I do Control V. And I've copied the same value labels to this variable. The only thing is I have to change it, right? I have to update it. So we actually don't have 0. We don't have 8. And we don't have 9 in this variable. And we also no longer have 5. So actually I'm going to copy this text, but I'm going to remove that option. And 4 now equals dislike it, as well as dislike it very much. So I'm changing the label on 4. And then I have to click change. Okay, so you'll see that's been updated. And then I can click OK. And that now has changed the labels on this variable so that labels will be included in my output. Now I can go back into the menus and do Analyze Descriptive Statistics crosstabs again, right? Analyze Descriptive crosstabs. And I can change everything using the menus. But I want to show you how you can use the syntax to make your life a little bit easier. The only change that's going to be made here, so I'm going to copy this text. I'm on a Windows machine, so I'm using Control C, but you could do your Command C if you're on a Mac. I'm pasting here. The only thing I'm changing is this. I've created a new variable country 2. So I'm going to run this country 2 by race. I'm going to highlight this and then click the run selection button. And if I come over here to the output, you can see now I've got a new table. Like it very much, like it, mixed feelings, dislike it / dislike it very much combined. And you can see now I have 0 cells that have expected counts less than 5. Problem solved. My Pearson chi-square has a significance of 0.000. So just like before, it's the same. It is statistically significant. And my Cramer's V value, so this is still Cramer's V because it's 4 by 3. It's not 2 by 2. So it's Cramer's V with a 0.135. This is, again, a moderate relationship. It's actually, that one cell with an expected count less than 5 didn't really mess things up very much. But technically speaking, you don't want to have cells with expected counts less than 5. So this is the fix. This is how we did it. And we have our new table, no more problem, and we have our results.